Hello, my name is Shalanda Chaudhary, and in this video I'll show how to set up TLS or SSL termination in Application Gateway. However, instead of using the self-signed certificate, I'll be using the Let's Encrypt CA signed certificate. So let's start with the introduction first. What is TLS termination? So it is a process of terminating the TLS encryption of incoming HTTPS request at the application gateway. And then the request will be passed on to the backend server in an unencrypted form. Application gateway acts as an intermediary where SSL or TLS certificate is used to decrypt the incoming HTTPS request. So the benefit of using TLS termination with application gateway is that it can offload the resource intensive task of encryption or decryption from the backend servers, which overall improves the performance and scalability of web applications. However, application gateway supports end-to-end TLS encryption, but in this case, I'll be talking only about TLS termination. Now let's set up the TLS termination in the lab. I have pre-created the resources used for hosting the Windows IIS server using application gateway. There is one virtual machine which is created. As you can see, web server 001. It's a Windows 2019 server. I have installed an IIS role in it, which shows the default IIS page. I'll RDP to the web server, and if I'll open the browser, localhost, as you can see the default page for IIS. And if I'll show the IIS manager, this is the default setup. No changes has been done here. It's a default website which is created when you install the roles using server manager. So let's go to application gateway. An application gateway is created where a backend pool is created with the name web server pool. And in the backend pool, the same web server is added here. For the backend settings, there is a setting for port number 80, which is HTTP. So right now our web page will be listening only on the port 80, which means HTTP protocol. For the front-end IP, there is a public IP configured for application gateway. If we'll go to the listeners, there is a web server listener which is created, and it's also listening to the port 80 on HTTP for the front-end public IP of load balancer. And finally, the rule which is created. So for the listener which is listening to the port 80 on the front-end IP of the load balancer goes to the backend pool, web server pool. So this is the very basic configuration which has been done on application gateway. And if we'll just open the public IP of the application gateway, it will show the default web page. And as you can see, the default page is visible now using the front-end IP of application gateway. To set up the TLS termination, we need a domain name, and I have created one DNS zone with the domain name which is already registered with me. There is a domain name devsecopstech.online, as you have seen in the previous video too. An alias record is created for the front-end IP of the application gateway. So that means if we open the devsecopstech.online, it shows the same default page which was showing for the front-end IP of the application gateway. And when you view the site information, you see that this site is not secure because it's using HTTP protocol, which is port 80. So to make it more secure, we'll now install the TLS certificate in application gateway. And for any incoming request from the browser, all the TLS termination will happen at application gateway itself. However, from application gateway to the backend servers, the connection will still be non-secure and it will use the protocol HTTP, which is port 80. If we use the self-signed certificate for the TLS termination, then every time a new connection is established from a browser to the application gateway, the self-signed certificate has to be trusted by the browser. However, to make it more real, I'll use the Let's Encrypt CA signed certificate. So as you can see, this is the Let's Encrypt website, and they are a non-profit certifying authority which provides CA certificates for free. Let's Encrypt uses ACME protocol to issue a certificate. There are multiple third-party clients which are available to generate the certificates. The most recommended is Certbot. However, this works well in Linux-based servers, and we have Windows IIS server. So for that, WinACME works well, which works on .NET. So I'll be using WinACME for generating the certificate. So let's go to our web server. Open the browser, type win-acme.com and download the latest WinACME. Save it. Open folder and extract everything. Now this is the application. Let's run this application. We have to trust it, run anyway. Now we can create a certificate using the default settings. But in this case, we don't want to use the certificates on this Windows server. We want to generate the certificates and use on the application gateway. So for that, we'll use full options. Let's type M and read bindings from IIS. Yes. Let's press enter because one is already selected. But there is one problem. It's telling that no website with the host bindings has been configured in IIS. So for this, let's open the IIS manager. And let's check the bindings. And as you can see, there is no binding. But we want to generate this certificate for our domain name. So let's provide the domain name here. Okay, close. Let's go back, try again, type M, read the bindings. And now it shows that there is a default website. Let's select this, pick all the bindings. And from the bindings, it has found that it's for the domain devsecopstech.online. Yes. So just type enter. And we want to use the single certificate because application gateway only accepts a single certificate. Yes. Sub verification file from the memory. Yep. RSA key. Instead of saving the certificate in Windows Certificate Store, we'll just use the PFX archive because we want to generate a PFX file. The reason why we are not using the Windows Certificate Store is because when we export the certificate from Windows Certificate Store, it doesn't let us export the private key. So use 3. So let's get the C drive itself. Set up a password. Number 2. We'll type the password now. Now we don't want to save it in Vault. No additional steps. We are done. We don't want to open it. We agree. This is just a demo, so I don't need to renew it. If you're using the certificate which has to be renewed after 90 days, then provide your email address so that you will be notified when your certificate will be expiring. I'm not providing anything here. And done. It will generate a certificate for me. And as you can see, PFX file is generated, which is in C drive. So let's quit. Close this. And open the File Explorer, C drive. And here is the certificate. This is a PFX file which we'll upload in Application Gateway. Now to get this file out of the web server, I have created a Azure Storage file share account. So there is one storage account which is created for this. ST file share. And if you'll go to the file share, there's the share drive. Let's copy this information. Open the run. Change few values. And provide the credentials. I'll be using the access keys. Let me copy the password separately. And here you go. The share drive is open. Now I'll copy the certificate to this share drive. It's done. Let's close everything. Close the RDP session. I have to sign in again. So let's go to the storage account again. File share drive, browse and download this. Let's check the folder. And I have the PFX file in my laptop. Now let's go to Application Gateway. There will be no change in the backend pool because we are using the same web server. There will be no change in the backend settings because, as I mentioned, this is TLS termination, not end-to-end termination. So the connection between application gateway and the backend server will still be HTTP, which is port 80. Let's go to the listener. Let's create a new listener. Copy this name, use 443 or HTTPS. I'll use 443 here. HTTPS, it uses 443 port. Upload a certificate. Let's give the certificate name as DevSecOps Tech. Upload the file, downloads, and provide the password. And everything else will be default. Add. Now there are two different listeners, one for port 80, one for port 443. Now I'll create a different rule for port 443. Create a routing rule. Let's copy the name from here. 443. Set up the priority as 8 because it was 10, so I'm just setting it up 8. Select the listener as 443. For the backend pool will be the same, backend setting will be the same. Add. It took a minute or two and now the settings are saved. There should be two rules now. And let's go to DevSecOps Tech.online. Let's use HTTPS here. And as you can see, it's secure now. Because security is provided by the Let's Encrypt CA signed certificate. But there is still one problem. If we'll use the port HTTP for this domain, it shows as not secure. To change this, what we can do is we can set up the redirection on port 80. Let's go back to Application Gateway. And for the routing rule, which was for the port 80, let's go to the backend targets. And instead of going to the backend pool, let's set up a redirection, which is permanent. And the target listener will be 443. So that means if anything which is being listened on port 80 will be moved to different listener, which is listening on port 443. Let's save this. It will take a couple of minutes to save this. It's all done. And if we'll go to the website, refresh it, now it's secure. So if we'll try again for the HTTP, it'll go back to the secure. So that means if it's HTTP, it'll be redirected to HTTPS automatically. To summarize this video, first we have generated the Let's Encrypt CA signed certificate using WinACME. Then we created the new listener for port 443 and uploaded that certificate there. After making the new rules for port 443, now our website, which is devsecopstech.online, is using HTTPS protocol and is secure. However, you know that the connection between application gateway and the backend server is still non-secure. And I'll create a separate video for end-to-end encryption of application gateway. That's all for this video. I hope you liked it. Please like and subscribe. Thank you so much.